Welcome to this lesson on Exploratory Data Analysis with Airbnb data. This lesson is a continuation of the work that we did before this video, which was step-by-step data cleaning, followed up by a video on automated data cleaning with modularizing that data cleaning code into a function. To check out those videos, take a look at the description. I put the links in the description. I'm excited about this topic because EDA on its own is very powerful. It can help provide data-driven decision-making as is, but it also lays the foundation for any analytic project because once you get a comprehensive understanding of the data set, it actually helps inform any other steps that you might want to take in the analysis pipeline. Our plan of action today for our EDA is perform univariate analysis and multivariate analysis. Univariate analysis is just examining each feature one by one, and we're going to do that by taking a look at the numeric features and then the categorical features. For multivariate analysis, we're looking at a combination of features and seeing if they have an impact on one another. With numeric features, we'll look at those, and numeric versus categorical features, or with categorical features. Our target, or the thing that we're going to really focus on in this data set, is the daily price. To begin, we're going to load our packages. We'll be using NumPy and Pandas to manipulate the data frame. We'll call in our cleaning script that we created in our last video lesson. Clean Airbnb data is the name of the function. And we'll import matplotlib and seaborn for visualizations. Also include pd.set_option display.max columns so that I don't have any truncation of my columns and I can see all of the fields. Let's load our data set. Define this data set. This data set is the listings data that can be found on inside Airbnb's website. It's in the CSV format. We're going to call in our cleaning function, and our new data frame, once it's been cleaned, I'm going to call it df_clean. Our function name is clean Airbnb data. I'm going to apply it to the data frame, and so now the data is clean, with the exception of one variable that I found before. So let's take a look at the information. df_clean.info to get information about the number of records we have, how many columns we have, our column names, data types, and how much completeness the data set has. Here, I noticed after cleaning still, we notice that number of stars is an object format, and it's supposed to be in float data type because it's actually like 4.3 stars, so it shouldn't be reading in as a string. The reason why it's reading in as a string is that the missing values were coded automatically to none, N-O-N-E, and that caused the conversion from number of stars from float to object type. So let's transform that back. So we have df_clean stars that as type float, and then we're going to take a look at it again, and we have df clean info. Now we can see the num stars has been converted to float data type. Let's take a sample of the new data frame. I'll look at 3 rows. And let's talk about the data frame for a second. ID is just a scrape ID. That's the ID that was given during the data collection once it was scraped from the Airbnb's website. Name has information like the type of rental it is, how many stars it received, number of bedrooms and bathrooms, and we use the name column to create our number of bathrooms, shared bathrooms, number of bedrooms, and so forth. Host ID is just the ID given to each host. Host name is the host's first name. So our host name here for this particular unit is Blake. The neighborhood is the unit is in the 2nd Ward neighborhood. This is the latitude and longitude for the neighborhood. The type of unit that Blake has is an entire apartment or entire home or an apartment. The price per night is $86. He only requires that person book for one night. That's the minimum number of nights. Number of reviews is 20 for this unit for the lifetime that the unit has actually been listed on Airbnb. The last review date was September 18, 2023 for this unit. The number of reviews the unit has received per month on average is 3.41 reviews. The calculated host listings count says that Blake only has one unit listed on Airbnb. Down here you see a 7. That means this host has 7 units listed on Airbnb. The number of days available remaining out of 365 days to book this unit is 80 days. So it sounds like it's kind of popular. The number of reviews in the last 12 months for this unit is 20. Number of bedrooms is 1. Number of bathrooms is 1. Number of beds is 1. No shared bathrooms. The number of stars for the unit is 4.65 stars. We created this has star rating column in the event that there were no stars, and so we have true when there are stars, false when there's no stars, and those that come up as false are units that have very low traffic or are likely brand new units or brand new listings. Anytime you begin any EDA, any analysis, you always want to come in having some questions in mind before you start, some sort of hypotheses or ideas around what you're even looking for. So for this, I came up with a few questions. Now you might have questions, but you may not be able to solve the questions that you have, or you may even come up with some additional questions that you would like to explore deeper from the EDA. That's what makes it so powerful. So the questions that I have for our univariate analysis are: what are typical listing prices per night? Do all listings come up with $86 per night? Is that typical? Is it typical to be between 86 and 100? So those are things I want to answer. What are the minimum number of nights for booking? For this data, how many listings do hosts have typically? Are there more or less days available for booking in Albany? What do the units offer in terms of number of beds and bathrooms? Are the listings in Albany highly rated? So these are some questions that I wanted to ask. What I'll do, because I wanted to actually separate out my numeric columns just to look at them. To do that, I'm going to go df_clean .select dtypes, include those that are int for integer 64 and float for decimals 64. Where I'm getting int 64 and float 64 from is this information here. I want to see the columns. So numeric underscore calls dot columns. Here we see that these are the numeric columns. Latitude and longitude, I don't want to keep that because I'm not looking at latitude and longitude the same way I'll be looking at price and minimum number of nights. So we'll remove those. So numeric calls now, I'm going to filter it down to just those columns without latitude and longitude. We need double brackets here. So we're going to have df_clean, remove latitude and longitude. So now we have our price there in front, and there we go. What I want to do next is to take a look at the percentiles. Before we get to this column, before we get to this row here, let's take a look at how easy it is to get a look at the spread, the average values, the min and the max, the 5-number summary, if you speak, so to speak, very quickly by just saying .describe, and there it is. It gives us the price. So for the price column, we see that the count is 391 because we have 391 records. The average price is $129.90 per night. The standard deviation is $115. To kind of tell you something about the spread of the values. The minimum price per night is $27. Half of the units are priced above $106 per night and half below. 75% of the units are under $144.50 per night, with the max unit price of $1,470 per night. And we can actually just go in and take a look at the data like this throughout. Now, this second row, I created this one because I noticed that if we scroll further to the right, we have so many columns that we miss the information here for the count, mean, standard deviation. As soon as I get to availability, I can't really see, those values. So to do that, I wanted to filter the data frame, or just take a subset of the data frame. Here we're taking a numeric columns, and we're going to take the index, and we're slicing the data frame. So here we have all rows, or all records, and then the first 5 columns from 0 to 6 not inclusive. So we can also take our percentiles and determine or specify whether or not we want 10%, 25%, 50%, 75%. Here we get 25, 50%, 75%, but here I wanted 10, 25, the same 25, 50, 75%, but with 90% and 100%, which is just the max. So here we see that. So now we have price, which is 0, 1, 2, 3, 4, 5. That's up to 6. That's what that is. So this is 5. And now we can get a look. We already saw price. We can see that 90% of the units will be under $199 per night, with 10% above that amount. When we look at our minimum number of nights, 90% for minimum requirement of nights to stay before booking will be, are under 10, with most of them being like 1, 2, maybe 3 nights requirement. For number of reviews, we're saying between 18 and 56 reviews typically for the units, because that's between 50th and 75th percentile. Reviews per month. This is a small spread for reviews per month. Here maybe between 1 and 2 reviews per month. Calculated host listings count. The number of hosts, most hosts have under 12 units. Between 3 and 7 units is what I would say. I'm looking at the 50th and 75th percentile to kind of get an idea, gauge that. And when we take a look at availability, we see that more than half of the listings have 258 and more days of availability. Let's review the percentiles for the remaining columns. So what we're going to do is keep the same code. And now go from 6 to the end of the number of columns that we have remaining. And now we can pull in number of reviews for the last 12 months, number of bedrooms, and take a look at those. And we look at the number of reviews in the last 12 months, between 23 and 623, I would say. So still looking at the 50th and 75th percentile. So we can see that only 25% of the reviews, 25% of the number of reviews are above 23 and above, with most of them lying beneath 23 reviews in the last 12 months. Number of bedrooms, very little change or variation in the number of bedrooms. Here you see 1, maybe 2, but more than half are just, less than half, about half of them have only 1 unit, and the maybe above that 25%, above the 50% mark, has, let's say, around 2. So that's what we can see for number of bathrooms. Number of bedrooms, and number of bathrooms are similar. Number of beds also similar. Very little variation. Shared bathroom, and you can see that too in the standard deviation. The low amount of variation there. Number of stars. Again, even less variation in number of stars at 0.27. And so when you look at the number of stars, we can see that, like most of them are above 4.5. Most of them are above 4.5. And so, that's high ratings. To answer one of the questions that we had before, like, is Albany highly rated? And it appears to be, at least from this data set. All right, this is nice to be able to take a look at the percentiles, but you may want a more visual way of looking at the data. So another way we can do this is take our numeric calls. and get a histogram of them. But I want to be strategic with the histogram because there was so little variation in number of bathrooms and number of bedrooms, and I decided just to focus on the ones where we had more variation, like price, which is our target, which is the one field that we're really looking at to see how the other ones are impacting the price, and a minimum number of nights, number of reviews, and calculate host listings count. I've done this a couple times, so I know that if I try to plot all of them at the same time, it'll be hard to see. We have some overlap in the figures. So let's grab the first three, which are these columns here. Okay, and so for numeric calls, I had numeric calls, price. Oh, one thing I did forget. I need double bracket here. So, okay, there we go. So we need the double brackets because we have more than one feature that we have that we're trying to subset on. So we do definitely need a double brackets here. So you can see with price, we do still see the skew with price. Minimum number of nights is a little bit more tight, and we also see skew with number of reviews, where you have most of them clustering under 200 with some smaller ones that go out as far as 600 reviews total. Same with price, where you can see the price is typically well below $500 per night, with some trending much higher than that. And let's take a look at this for the same thing for the availability column, the calculated host listings count, and the availability columns. And here we look at the calculated host listings count. Here we say, okay, most hosts have 7 and under listings, with a lot more having fewer still. And we look here at availability 365, where we almost look like there's a split. You have some that are lumped here where there's a lot of availability, and then you have another almost like half that don't have as much availability. And so these plots are similar to what we saw in the data themselves. To get a look at the distribution a little bit better, I'm going to use Seaborn for the price. So we're going to look at the price column, histogram of the price column. This plot. And so here, when we take a look at this plot, you see again the same, similar to what we saw here, but in the first plot for price, a little bit more granular because we have more bins, and you can now more clearly see that okay, under $200 is what you would typically see for a daily price for a rental or a listing. I would like to get a better view of what it looks like when it's under $200 and under, or at least under $400. So let's trim the data set. I think this is ax.set xlim to listings by price. Okay, and so here this allows us to trim the long tail that we had up here. And so now we can see more clearly something that that we have a bimodal distribution. So right here, we have a hump here, and then we have a hump here. And I will wager that at above $150 is where we may see more luxury units, and under 150 is probably the typical unit, with those that are below around that 50 being more of a low end type of unit, or maybe a shared room. Or definitely not an entire apartment. Let's take a look at the availability, and we'll do the same thing for availability. And availability 365, which is here. Here I also kept the limit from 0 to 400, and we can see for availability that we have a good number that have in excess of 250 days still remaining, and then some with less of that. So it's what we saw before. It's pretty consistent. Let's take a look at one more. Let's see. Number of reviews. This was number of reviews. I think it was here. By number of reviews, and that's okay. We could clean it up, and that's fine. And here we have number of reviews. I would trim the number of reviews so I can get a better idea, because anything that's above 150 is just high. It's high. So let's trim it to, let's stop it at 150 and see what happens with that. Okay, so you get a good look and see that most of those reviews are going to be under 20 under, or 40 under. A lot more of them being around 10 or so. For minimum number of nights, we can do the same thing. How about number of nights? Okay, minimum number of nights, we definitely need a different scale here. We can see the sum will go out as far as 60, but let's stop it at 40 and see what happens. Here. Okay, we can see that, most minimum number of nights requirement is 1 or 2 days, and we saw that with the percentiles. So those are the univariate numeric analysis. Now let's move on to the categorical analysis. As before, we're going to take, I'm going to call this cat calls for categorical columns. And this time we're going to include those that are object data type. And we're going to take a look at the columns. And these columns are ID, name, host name, neighborhood, and room type. Let's take a look at neighborhood and room type first to see what the counts of those neighborhoods, which neighborhood is the most represented in the data set, which room type is most popular. And then we'll come back to take another look at the popularity of the host. So we'll look at neighborhood. And we look at neighborhood and also room type. I could have grabbed both of those. And because we have two features that we're trying to take a look at, we're going to need our double bracket. And we're going to now describe on these categorical columns. And what it tells us is that for neighborhood, and room type, they both have a count of 391 records, and that there are 15 neighborhoods, and the most popular neighborhood, or the top most represented neighborhood, is 6th Ward with a frequency of 90 out of 391. As far as a room type, there are 3 types of room types. The most popular room type to be rented is the entire home, or be listed as the entire home/apartment. And there are 275 out of 391 room types are entire home/apartment. To look at what those value counts look like for the other 15 neighborhoods, or the other 14 neighborhoods with 6th Ward, we'll do a bar plot. Neighborhood. Kind is equal to bar. So for our bar plot. Okay. And we see that the 6th Ward is, of course, the most common, followed by 2nd Ward, 10th Ward, 9th Ward, 3rd Ward. And it'd be interesting to find out, well, for 6th Ward, you know, how much are they, what's the price look like for 6th Ward? You know, how much is the charge on 6th Ward? So we'll look at that when we take a look at our box plots to see what's happening with price related to neighborhood. For our bar plot and room type, we'll do the same. And this df clean room type is the next thing that we're working on. So df underscore clean room type for value counts. So here we see that entire home apartment is indeed a lot more represented than the rest of the room types. We have private room, we have shared room, coming in very low, very few shared rooms. To take a look at our top 10 hosts, we'll do the same. We'll take something similar. We're going to create a little data frame for hosts, and this will be a host name. I think it's host name. Yep, this is host name, so let's get that. So we have host name, and we will have the value counts, and I want the top, because there are a lot of hosts, and I want all the hosts. I don't want to plot all the hosts, I want to plot just the top 10. So I need to sort these values. So we're going to take the value counts for the host, how many times they show up in the data set, and we're going to sort them. Sort values ascending equals false, because I want them from top down, not bottom up. And we're going to go host plot kind equals bar. Oh, I forgot to get my top 10. And this is what happens when you don't do the top 10. We have to go from 0 to 10. So 0 to 10. Now we can see what our hosts are. The top host is Diana, followed by Tara, Linda, Elizabeth, and so forth. And we have our multivariate questions. Now this takes us to our multivariate section. And the questions I had were like, is the listing price related to the number of listings the host has? Are the number of reviews related to the listing price or number of bathrooms? So these are different questions. So to take a look at comparing the numbers with one another, we're going to look at the correlations to see if there's any relationship, any linear or positive or negative relationship between numeric features. We got core. We'll do that, and we can look for a correlation. And we're interested in seeing how things are correlated with price, because price is what our focus is. That's our target. It's what we're interested in. You can see that when you have a diagonal of ones, they're perfectly correlated because price is going to be perfectly correlated with itself, as well as minimum nights and number of reviews with number of reviews. The closer we are to 1 or -1 shows a stronger relationship. If it's negative, then it says that this thing price actually goes down when this thing goes up. So in the case of minimum number of nights, when the minimum number of nights increases, then the price is supposed to goes down. What you notice here is that this number is very small. So this is like negative 0.05. It would be a nickel if we were looking at money, or almost 6 cents. Same thing for number of reviews. More reviews, it seems to indicate a lower price, but the number is so small that we can't really count on that. Now, where I am saying something that is a little bit higher is at 0.18. It says the calculated host listings counts. So when the host has more listings, then the price may be a little bit higher per night. Here, this is a smaller number. This is still small. And here are where the bigger numbers are showing up. Where we're seeing number of bathrooms have some sort of play on price. When you increase the number of bathrooms, then the price will also be more per night. Same for number of bedrooms and number of beds. These are related. Number of beds, number of bathrooms, and number of bedrooms are related. And you can see that in the correlations for those. So if we want to just take a look at the correlations of number of beds, number of bathrooms, and the price, we can do that. We can take our numeric calls and just take a look at the number of beds and number and price and calculate the host listings count. Let's look at all of them. Okay. And so when we look at these, number of bedrooms, and look to see how they are related with one another. Number of bedrooms versus number of bathrooms is a high correlation. Number of beds and number of bathrooms is almost perfect, because the number of beds is going to be dependent on how many bedrooms you have. And then we have the number of the price. We see the calculated host listings count when with number of bedrooms is low, bathrooms is low, but the price is a little bit higher. So yeah, those are things I would probably focus on if I were doing some predictive analysis with this. I would look at those features and would choose one. I wouldn't choose all of the features. If we want to take a look at this in terms of a scatter plot, scatter matrix, you can do it with a scatter matrix, looking at these same columns. This is the code for that, where I pulled in those columns. And here we had our set the theme to text style, the font scale of 1.8, because before the font was very small, so I had to increase the font scale. And yep, and so here those are our columns, and you can see it here with price and number of bathrooms. We have some overlap there. You can see somewhat of a positive correlation that's almost diagonal in a way, where the dots are lining up. The same for number of bedrooms and number of bathrooms again. And so that's what you can see here from this. I get a better view when I look at the heat map. So we have SNS.heatmap for Seaborn, and we just put our data frame in the columns that we're interested in with the correlation, and then show. And so this is our heat map. And the lighter the value, the more closely aligned it is to 1. The darker, here it's closer to 0 as far as correlation. And what we're seeing here is that the prices has correlation, as we said before, with number of bedrooms and number of bathrooms. And that number of bathrooms is correlated with number of bedrooms, and is very highly correlated with number of bedrooms is highly correlated with number of beds. It should be number of beds. Did I include number of beds? I didn't include number of beds. Number of bedrooms and number of beds, I didn't include it. Okay, now here we go. So number of beds and number of bedrooms we see is highly correlated. And we saw that from the correlations when we just plotted the correlations out. If you want to add the annotations, you can. So we can do core annotate equals and it provides the annotations too. So you can actually see what the correlation is. So number of bedrooms is 0.99 with number of beds. Yeah. So based off of this, I would not, because number of bathrooms is correlated with number of bedrooms and number of beds, I would only include one of those three features, and it would be the number of bathrooms because it's more highly correlated with price. So that's how I would look at that initially. Multivariate questions and answers, categorical to number, and for this one I'm going to use a box plot. So we're going to take a look at the neighborhood and see what happens with the price. Cut this for a second so you can see what happens without the show flyers, and this one too. Okay. So if you just do SNS.boxplot and let X be the neighborhood and Y be the price, you end up with this view. And this view, we see that we can't see all the neighborhoods. So we'll add the plt.xticks and we're going to rotate it by 90 degrees. And now it allows us to see the neighborhood. And because there are so many outliers, it really compresses the graph, so it's harder to actually see where there's a difference in the neighborhoods with regards to price. So then we'll add this show flyers equals false. Okay. So we don't want to show the outliers. We'll call it show flyers. And so now we can have a better view of being able to see what the impact the neighborhood has on the price. Remember, 6th Ward was the most common neighborhood, most highly represented within the data set. And in terms of price, it's not highly priced. It's nearly kind of like almost a little bit above the typical price point for a unit. We saw our typical price between 144 and like 120 or 118. So some price around there is what's typical. And when you look at the 14th ward, we see the 14th ward and the 11th ward can get into some very low prices. The highest priced neighborhood is the 15th ward and the 8th ward. So those are good to see. This is how we can compare the categorical with the numeric features. And so now we're going to compare the room type with the price. So this is our neighborhood and we have our room type. So close room, let's go type. And we're going to remove the outliers and still keep our, I don't think we need a rotation here, if I can remember correctly. Well, yeah, we did. We need a rotation. All right. And so we can see that our private room in our entire apartment, that the entire apartment or home has a higher price point. That's a higher price point. And there's you can see that the middle 50% is showing that 50% of those private rooms are probably under $70. When you look at it. So it's like yeah, it's probably under $70. And so yep, that's what we can see here. And so there's like a little bit more variation, I think, that you can have prices that can go very high and also very low for those private rooms, and a little bit more stability in our price point when compared to the entire home or apartment. Shared rooms are very very small. I think we're saying that the price can be almost on par with an entire home or apartment based on the area. That wouldn't occur in some other places. Like we're looking at New York. They're saying in Albany, New York, that might be more of a thing to have less space in that area, in that region. And so people pay more for less space. Okay, I want to thank Lean Rem from Stack Overflow for this plotting code. I thought it was a nice extra to be able to actually plot the latitude and longitude and actually get a visual geographic view of an analysis and do some analysis that way. And what I did is I included the color scale is orange red, and I'm using Lean Rem's code and just kind of altered it a bit so that we could have the hover name be neighborhood and the data be neighborhood and availability, along with the color showing the price, and also the size indicating the price. So the bigger the circle that you'll see coming up will indicate that it's a more highly priced unit. And so here, this is what we have here. I'll include this code in GitHub, as well as, and I'll put the link in the description for the code. But yeah, this was pretty awesome. When you look at the data set, you can see that the larger circles, they're occurring on the main roads and those main arterials. So this one's all, if you look, here we have Madison Avenue. And that's where we're seeing the bigger circle here. The nightly price is $850. In the neighborhood is a 9th Ward. Drag it up some more. This is again a close. This is 10th Ward. The price is, that's the small one. The bigger one, the price is $600. It's in 10th Ward. And it has 78 days of availability. The one we saw before had 179 days of availability. This one has 336 days of availability and is priced at $1,470. Some of the smaller units, priced at $90, has 168 days of availability. It's in 9th Ward. So this was just interesting. Okay. Here, this one is 2nd Ward at $599, 364 days of availability. And just look to see where it's located. You can see on the main, on those main thoroughways or main streets are where you're seeing higher price points. Okay, so yeah, this brings us to the end of our EDA. Definitely check out my next video. This next video is going to be automated EDA. We'll be looking at suite viz and data profiling. So stay tuned. And until next time, definitely give me a thumbs up, like, subscribe, and until next time, be well. Thank you.